Okay, welcome back to Python programming. So as I told that in the previous video, in the same fruitful functions will be continued in this video, and this video comes under the Boolean functions, more recursion and checking types. So fruitful functions is mainly deal with this Boolean functions, more recursion and checking time. So again we'll see the fruitful functions. What are those? So these are all the three lectures I am discussed as I completed the two lectures 12 and 13. So here we are discussing now is Boolean functions, more recursion, checking types. So this is the lecture. In this video we are going to discuss. So what is meant by Boolean functions? So you all know this true and false, which is hiding, which is a complicated test inside functions, and functions can return booleans for hiding complicated test inside the function. Division, defining is divisible x comma y, x modulus y is equals to 0, return true, else return false. So we all know that x, we are defining some x value and y value. Based on that, if e is divisible, x comma y is equals to true, print x is divisible by y. So this is the way to define the Boolean functions, where we can take that return value as true or false. So this is the Boolean function. Next, coming to the Boolean function, more recursion. So defining factorial of n. Here I am taking the example as a factorial of n. If the argument happens to be 0, all we have to do is return 1. When we defining the function as a factorial of n, if n is equals to 0, then return 1. So this is the more recursion way which defines. So here same we will take the factorial of n. If n is equals to 0, return 1, else recurse is equals to factorial of n minus 1, result is equals to n star recurse, return result. So this is the recursion value. When we seen in the interpreter, it defines the factorial of the n, that defines n is equals to 3, recurse of 2, result 6. Next, n is equals to 2, recurse 1, result is 2, and n is equals to 1, recurse 1, result is 1. Whenever n is equals to 0, then again the else statement will be defined. So this is the more recursion. Next, coming to the checking types. Defining, here I am taking the Fibonacci series as example for checking types. We have to check the type, what type of category, what type of way we gave here as a Fibonacci. So if n is equals to 0, return 0, else if n is equals to 1, return 1, else return Fibonacci. Then n minus 1 plus n minus 2. What happens if we call factorial and give it 1.5 as an argument? Factorial of 1.5 is nothing but totally runtime error, maximum recursion depth exceeded. So this is we can call it as a checking types. And here if we take we can use the built-in function is instance to verify the type of the argument. So if we take this type of code, factorial is only defined for integer and will return the none value, else factorial is not defined for negative integer. If n is equals to 0, return 1 or factorial of n minus 1. Next, this is about lecture 13, and so this is we discussed in this video Boolean function, more recursion, checking type. So this is the completion of lecture 13, fruitful function. Hope you all understood about these two lectures about fruitful functions. So thank you very much.